class. This video is about in behavior, what it is and how to write it, how to describe it. So when we're talking about in behavior, we're describing what happens to the graph. What happens to the graph is the x values get really large or really small. So the in behavior is the behavior of f of x as x goes to infinity or negative infinity. So you can see as I have as an example here the parent function y equals x squared, which is a quadratic, a basic parabola. And so we can see that here's my f of x, that's the graph. And I have my x-axis down here. Well, as the x-axis is getting larger and larger and larger, that's coming out this way, is that it goes out into infinity, right? As this is going out towards infinity, what is happening to the graph? Because the graph will also continue forever. The graph will continue forever, and also we can go out to infinity. So as we go out to infinity, what is happening to the graph? Yeah, that's right. The graph is going up and up and up and up and up, and the graph itself is headed to infinity, isn't it? So f of x is going to infinity. And what's happening on this side? That is the in behavior. The in behavior says that this graph is going to infinity. So what happens on this side of the parabola? As the x values, that's this x-axis, is going smaller and smaller and smaller this way forever onto infinity. Well, as the x is getting smaller and smaller and smaller, the graph is still getting larger and larger and larger on this side. So on this side, the graph is also going to infinity. So the in behavior for this graph is that on either side, it's going to infinity. So how will we write that? Okay, so the format for writing in behavior is that the in behavior, you write it like this. It's always going to have two parts. First, we're going to say the function is approaches, this arrow means approaches, something as the x value is approaching something. So let's say, let's do this side, let's do the right side here first. Here's the f of x. F of x on this side, okay, is approaching, it's going up, so it's coming to positive infinity. It's approaching positive infinity. F of x is approaching positive infinity as x, here's my x down here, is approaching, again, positive infinity. But it's not enough to just describe this side. When you're writing the in behavior, you always need to include both pieces. What's happening when x is going to positive infinity and what's happening over here when x is going to negative infinity. So over here, f of x, it looks like the function on this side is also going to positive infinity. So x is approaching positive infinity as x is approaching, here's the x, it's approaching negative infinity. Always write in behavior in this exact same format. Okay, so here's an example of in behavior. Now I've changed to a different parent function. This time, what parent function is this? Which one goes up like this? That's exponential, isn't it? Okay. So here I have my exponential parent function, and let's see if we can write the in behavior. Let's start on this side. On this side, here's my f of x. What is it doing on this side? And it looks like on this side, the f of x is headed up and up and up towards infinity again. So it looks like f of x approaches infinity, positive infinity, as x on this side is approaching infinity. What about on this side? It doesn't look like my function is going to go on and on to negative infinity. It's kind of leveling out here, isn't it? What value is the function approaching? It's getting closer and closer and closer to 0. It looks like the function itself is getting all the way down closer and closer and closer to 0, to the 0 line. And what is the x value doing? As the x value is getting closer and closer to negative infinity. So f of x approaches 0 as x approaches negative infinity. Okay, so when you're looking to find the in behavior, there are two things that affect the graph. Well, the degree and the leading coefficient are going to determine the end behavior. So let's look at the leading coefficient first. If the leading coefficient is positive, then the graph is going to end going up. Okay, so for example, here is x to the third power. Okay, the parent function for that looks something like this. But notice on the right side that it's ending going up. Here's the graph, here's the parent function for square root of x. Okay, notice that it starts here and it kind of goes like this. But how does it end? It ends headed up. Or we could just have a line. What if we just have x? The graph of a line. It ends going from left to right. It is headed up. Now let's compare that to what happens when the leading coefficient is negative. When the leading coefficient is negative, the graph ends down. All right, so if I had negative x cubed, then that graph would look something like this. It ends going down. Or if I had negative square root of x, the graph is going to end headed down. Or if I had negative x, then the graph ends going down. It doesn't matter how it starts. I'm not talking about how it starts. I'm just talking about the right side. The right arrow will reflect whether or not that leading coefficient is positive or negative. And then the last thing that will affect the polynomial is its degree. So if the degree of the polynomial is even, then the endpoints of the graph will end in the same direction, either both pointing up or both pointing down. But it'll be the same, in the same direction. So for an example, this graph here looks something like this. So I can see that the degree here is 4. So I draw this 1, 2, 3, 4, okay? And the beginning started with up and it ended with up. Same thing for x squared, right? If we have squared, if I have negative x squared, okay? And then it would end down, begin down, and end down. Okay? The reason it's beginning and ending both facing down is because it's even. Let's compare that to what happens when the degree of the polynomial is odd. If the degree of the polynomial is odd, then the graph is going to end in opposite directions. One going up, one going down, or the other one going up and the other one going down. So for example, here I see that this leading degree was 4. Here I can see the leading degree is 5. 5 is an odd number. So when I sketch this one, 1, 2, 3, 4, 5, it might look something like this. I can see that one arrow is pointing down and the other arrow is pointing up. So odd degree, they're going in opposite directions. Same thing with negative x cubed. Okay? Negative x cubed, I have 1, 2, 3. One arrow is going up, the other arrow is going down. So when you're looking to find the end behavior, pay attention to the degree and to the leading coefficient.